Alright, hi everyone. We're looking at the last assignment for work energy power. Okay, so as usual, like I said, you do not have to finish the entire solution video with me. You just have to skip to the question that you really need help with. So you can just click on the shortcut, alright, from the description box in the YouTube video. Okay. So now let's take a look at the first question. All right, this is actually a very good question, and I would say it's a database question, so it could be probably found in the section B of your paper 2. All right, so question 1 says the diagram shows a car initially at rest, rolling down a hill with its engine turned off. A student uses ideas about energy to produce a spreadsheet to model the motion of the car. So the student assumes that there is no air resistance or friction. So the student spreadsheet is shown in the table below. Okay, no air resistance and no friction. So we're not talking about any energy loss. All right, so any energy conversion will strictly be between your GPE and a KE, right? So the mass of the car used in the calculation is 860 and G fuel strength is 10. Okay, explain how values of the GPE in column B are calculated from values of the height of the car in column A. Okay, so how are they calculated? Based on the formula, right? So based on the formula mgh, where you need to be very explicit here. Do not just throw in what the formula, because you need to know, you need to explain what they are. M is the mass of the car. G is the G fuel strength, please spell it out. And height, H is height, from column A. Okay, be very explicit, because that is what the question wants. They're specifically asking, how do I calculate the values from B from A, for B from A? So you need to tell them how your A plays a part in the calculation of B. So over here you see I put H is the height from column A. Okay, calculate the height of the top of the hill. So we're going to use the formula now. So let's take a look at this. The second row, top of the hill, this is the total amount of GPE, right? So if it drops to the bottom of the hill, okay, it will lose this amount of energy, right? So change in GPE equals to mgh. So how do I find h? Will be change in GPE over mg, right? So what is the change? 1118,000. 1118,000 over m is 860. Is it 860 multiplied by 10? Okay, wow. So it's 1118,000 divided by 8,600. Okay, so the height of the hill is 130 meters. Okay. Using the principle of conservation of energy to explain how the values of the kinetic energy were calculated in column C from the values in column B. Okay, let's take a look. Again, very specific. How do I get C from B? How? Can you see it? They will always add up to 1118000, right? Because energy cannot be destroyed. So how do we get C? So see, B plus C equals to 1118000, right? So how do I get C? Yep, 1118000 minus B. So since energy cannot be created nor destroyed, and can only convert, oh wait, the question already say use the principle of conservation of energy. Yeah, okay, so I'm going to elaborate a little more. And can only convert, ouch, since energy can only convert from one form to another. Okay, column B plus column C equals to 1118000 joule. Do I need to put a joule? No need. Okay, because in the table heading already has the joule. So therefore, column C equals to 1118000 minus column B. Okay? We need to be explicit. I need you all to write this down. Calculate the velocity of the car when the height of the car is 0. So when the height is 0, right? So if it is 0, it means what? This is the KE. Alright, so equals to half mv square. So V equals to, okay, so 2 times 1118000 divided by 860. Then you square root the entire thing. 2 times 1118000 divided by 860 is 2006, right? So we square root 2600. 50.990 meters per second. Round it off to 51.0 meters per second. Okay. Question 2. The diagram shows a conveyor belt carrying suitcases into an aeroplane. So an electric motor is used to drive the conveyor belt. Okay, this is the part that we see, that we don't really see as passengers. So a suitcase of mass 20 kg is lifted from the ground onto the airplane. Take a vertical distance of 4. Okay, just nice. Because when we talk about mass, we're talking about weight, right? Weight is always down. So we need the upward force. Just nice, they give me upward distance, right? Explain the difference between mass and weight. 2 marks. Explain. They are not asking you to state. So please do not tell me things like mass is constant, weight it will not be constant, blah, 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 blah. We need to explain. Mass is a constant. Why? As it is the amount of substance or matter in a body. Okay, weight is not a constant. It's not a constant, as it what is dependent on the G field strength. That it is in. Okay. All right. So W goes to mg. As long as the G changes, your W will change. Okay. Part 2. Calculate the increase in GPE of the suitcase. So increase in GPE, again the triangle sign. Change in GPE equals to mgh. M, they told you is 20 kg. G is 10, and height is 4 meters, right? So 200 times 4, 800 joule. Conveyor belt delivers 5 suitcases each minute. Average mass of each suitcase. Okay, so they want you to calculate the useful power output, right? Power output. So what's the power? So you see, power equals to work done over time. Work done is equals to force times distance over time, right? What's the force? They say 5 suitcases, right? 5 suitcases. So 20 times 5. All right. So that will be my mass, but I want to find force. So that's my weight times 10, right? And what's the distance? 4.0. Actually, all this, you can just use 800 times 5, right? It's the same because we already found for 1 suitcase is 800. So for 5 suitcases, it should be 800 times 5. All right, but I'm just going to reiterate the formula, okay? Over the time taken, do I just divide by 1 minute? All right, be careful, 1 minute is 60 seconds, all right? We want it to be an SI unit for this formula. So 800 times 5 is 4,000. So the work done is 4,000. 4,000, they use 60 seconds to work on it. So it's 66.666 watt. 66.7 watt. Okay. 3. A 500-gram electric car consumes 20 joules of energy in 10 seconds. Okay, so what is the power? Power equals to work done over time. They already tell you 20 joules, right? So we don't have to break it down some more. So it's just 2 watt. Okay? During the 10 seconds, toy car accelerates from 2 to 6 on a level road. So what is this? Kinematics, right? U, V, calculate the gain in KE. Alright. Oh, so we want to calculate the gain in KE. So remember, change in KE. Okay. What you want to do here is what a lot of students will do. Okay. I'll show you the careless mistakes that most students will do is this. I will just half m v square. So the change in v is just 6 minus 2. So you will do this. A lot of students will do this, trust me. 6 minus 2 square. So I will find this answer first. Okay, let's find the answer. So half times 500 gram, right? 0.5 kg times 6 minus 2 is 4 ma. 4 square. What is 4 square? Half times 4 square is 16. 4 joule. Alright. So a lot of students will give me 4 joule as the answer. But this is not the right way. Okay, to do this correctly, you need to find the final KE minus the initial KE. Okay, so it should be done this way. Then you will see and tell me if they are the same. Final KE, half m v square minus half m u square. What is the final? Half times 0.5 times 6 square minus half times 0.5 times 2 square. Mathematically, the values are not the same. Okay, I'm going to leave it to you to go and find out why are they not the same. But I'm telling you right now, never just straight away do this. Okay, you need to show out everything. So half times 36, this is 9. Minus half times 4, this is 1. So answer is actually 8 joule. You see? It's not the same. Alright, so this is the correct answer. This is wrong. Never do this wrong. Okay? Question 4. When large buildings are being erected, particularly on soft ground, piles are driven into the ground to provide a firm base. Alright, this is called a pile driver. The diagram below shows a pile hammer in operation. Okay, they call it a pile hammer. The pile hammer has a mass of 2,500 kg. So the hammer is here. Alright, this is the hammer, and this hammer weighs 2,500 kg. Or rather, has a mass of 2,500 kg. Calculate the loss of GPE when the hammer falls 1.8 meters. Alright, so loss in GPE. MGH 2005 times 10 times 1.80. Okay, so times 1.8 is 45,000. So by dropping the hammer down a height of 1.8 meters, alright, it loses 45,000 joules of energy. Determine the speed at which the hammer hits the pile. Okay, so this is according to principle of conservation of energy, right? Change in GPE must be equal to change in KE, right? So we already got 45,000. Alright, so so in this case it's 45,000 equals to half mv square. So the question wants you to find V. Okay, or alternatively you can use this also, V equals to square root 2 GH. Or you can straight away use the previous answer to find. You'll get the same answer. Okay, so it'll be 45,000, alright, times 2 divided by 2,500. Okay, and answer should be 6 meters per second. Okay, 6 meters per second. Verify it with this formula, you should get the same answer. C. The total mechanical energy of the pile and the hammer just after impact is 27,000 joules. Okay, so what is mechanical energy? How come there's a new term here? Alright, mechanical energy usually got to do with the machineries one. Okay, so we're talking about total potential energy, kinetic energy. Alright, so total thing that is moving, alright, and stored. So how much energy is lost? After impact is only 27,000, but initially I have 45,000. Okay, so how much energy is lost? So very simple subtraction question. 45,000 minus 27,000. all right, I should get 18,000 energy is lost as what? So what do you think happened? So every time when there's impact, there will always be sound, there will always be thermal energy. This, energy is converted to thermal and sound. Of course, some of the energy is, through the vibration, all right? So the vibration in the ground will also be converted to thermal energy. The pile is knocked into the ground a distance of 10 meters, so calculate the average frictional force exerted on the ground while it is moving down. Okay. So you see the energy, only 27,000 joule of energy is impacted on the ground. Okay, the rest are all lost already. So I'm not going to consider the loss. I'm only going to consider the 27,000 joules of energy that is transferred to the ground. Okay, it only allows the pile hammer to drive a distance of 10 meters. How come the hammer cannot go in deeper? Because the soil itself acts as a resistance, right? The soil itself acts as a resistance and it's going against the motion of the pile hammer. All right, that is friction. Okay, the soil has friction. So now it's talking about, average frictional force. So we'll be talking about work done against friction. Remember previously we have a lot of questions on friction, right? Work done against friction equals to what? Equals to frictional force. Hopefully you still remember this, okay? Multiply by distance. Okay, so what is the work done against friction? It must be the 27,000 joules, okay? Because this is the amount of energy that a pile driver has, the pile hammer has. As it exerts into the ground, it is always constantly going against friction and it travels 10 meters. Okay, so 27,000 joule is equals to frictional force multiplied by 10 meters, right? So what's the frictional force exerted? On the pile. So we just divide by 10 is 27,000. Wait. Wrong. Right. Newton. 27,000 divided by 10, 2,700. Yeah, 2,700 Newton. Okay. All right, I thought this is an interesting question. Okay. Is this the last question? Yes. Question 5. The diagram below shows a ram being used to get a load which has a mass of 180 kg. So the load has a mass of 180. So we're talking about this 1,800 Newton, right? Okay, don't get confused with the force that is 600 over here. Ram is 4 meters and the load of the lorry is 1 meters above the ground. Oh, okay, so they basically move it up 1 meters. The vertical height is 1 meter. A force of 600 Newton is needed to pull the load up the ramp. Okay, a force of 600 Newton is needed to pull up. Okay, so we already highlighted that. Calculate the GPE gained by the load as it goes from bottom to the top of the ramp. Okay, so GPE, MGH, right? What's the M? 180 times 10 times 1, right? The height is 1 meter, right? So answer is 1,800 joule. So to move the load up, the load would have gained 1,800 joule of energy. But the question for part B, they're asking you to calculate the work done. So if someone or something is actually exerting a force of 600 Newton and is pulling the load up a distance of 4 meters across the ramp. So what is the work done? Force times distance. The work done is actually 600 multiplied by 4. Actually, I did 2,400 joules of work on the box, on the load, so that the load can gain 1,800 joules of energy. What happened to the energy? What happened to the remaining energy? There's a difference there, right? 2004 and 2008, there's a difference of 600 joules of energy. So what happens? Right? Energy is lost. Oh, I actually put in some energy, right? Okay, but anyway, so let's take a look at C first. As the lorry starts, the load topples off, okay, and falls off to the ground. Determine the kinetic energy of the load just before it hits the ground. Okay, so on the load, now the load is on the lorry. Okay, so over here is 1 meter. So it drops. So on the lorry, it has 1,800 joules of energy, right? So as it drops, energy must be converted to KE. So according to the principle of conservation of energy, change in GPE must be equals to change in KE, right? mgh equals to half mv squared. Cancel, cancel, because we're talking about the same mass, right? V equals to square root 2gh equals to 2 times 10 times, what's the h? 1. Square root 20. Excuse me. All right, square root 20, right? So it's 4.4721 meters per second. 3SF 4.47 meters per second. Okay, so this is the velocity of the box just before it touches the ground. Okay, if it drops off from the lorry. So I'm going to go back to the A and B again. I mentioned, you see, we did 2,400 joules of work. The box only gained 1,800 joules of energy. Okay, so where did this 600, the difference, go to? All right, so some of the energy must have been lost as heat, thermal energy. All right, sound as you move it up. At the same time, assuming the box was actually moving at constant speed, means the box is not gaining any KE. All right, so this 600 joules of energy is lost. All these are considered as the non-useful work done. All right, out of this 2,004, only 1,008 is useful. Okay, so hopefully by now you should be able to catch all these details. All right, that marks the end of the 4 assignments for your work energy power. Okay, so if you have any question, feel free to come and find me, arrange a consultation. All right, if not, I hope these 4 assignments, the video solutions are more than enough for you to have a better understanding and a good understanding of this chapter. Okay, see you guys.